All right, so we're going to be looking at the statistics unit. And the first thing we're going to talk about is a measure of center. A measure of center is just a number that the data centers around. Okay, variability is also something we're going to look at, and it's just how spread out your numbers are. It could be how spread out your numbers are from a low point to the highest point, or how spread out your numbers are from the center, okay? All right, so the first measure of center we're going to look at is mean or average. Mean is the average number of numbers. It's calculated. It's a calculated central value. Again, that's all we call it, a measure of center. It's a calculated central value of a set of numbers or data. So to calculate the mean, all you do is, number one, add up all the numbers and then divide by the number of numbers in the data set. All right, so we're going to take a look at example 1. It says the table shows the test scores for several students in 2 math classes. So in class A, we have 6 students, and of those 6 students, one scored 82, the other one scored 84, 85, 81, 79, and the 6th student scored an 80. In class B, one student scored an 80, the second one an 81, third one 83, fourth 79, fifth 78, and the 6th an 80. All right, based on the information in the table, which statement is true? The mean for class A is about 1.7 points higher than the mean for class B. So if I'm looking at all of these, it's asking me about the mean. So I think what I want to do is calculate the mean first and then make the comparison. Okay? So I have 82 plus 84 plus 85 plus 81 plus 79 plus 80. So that's 491 divided by 6. So the mean here is 81.83. Repeating. All right, here we have 80 plus 81 plus 83 plus 79 plus 78 plus 80. When we add those up, we get 481, and we're going to divide it by 6. And that is 80.16 repeating. Now, I'm going to go back and add these up because I didn't write that total down for class A. So that was 491 divided by 6. So that's 81.83. That's how we got that. So I'm going to subtract those two. So that's 1.67. And it says the mean for class A is about 1.7 points higher. Of course, class A was higher, had a higher mean than class B. And it is about 1.7 because that 7 tells that 6 to go up to about 1.7. So it says the mean for class A is 1.7 points higher than the mean for class B. I'm going to go with A. Now, D looks about the same, but it says the mean for class B is about 1.7 points higher than the mean for class A. So it's switched up because B is not higher than the average for class B is not higher than the average for class A. All right, so next we want to take a look at this frequency table. When I say frequency table, that means like you have a certain number that will appear over and over and over, and you'll have to tally it up correctly. All right, so let's take a look at it. It says a supervisor at your company is examining the number of sick days that an employee that employees use per year. So let's make sure we look at the question. What is the average number of sick days taken? So I want to find out the average of those, the number of sick days taken per year. So make sure you read this table correctly. So for the year, 3 people didn't take any sick days, but 9 people took 1 sick day. So that's 9 times. And you all should be able to tell me what to do with this. That 1 appears 9 times. 1, 2, 3, 4, 5, 6, 7, 8, and 9. But then it says that 2 sick days were taken by 5 people. So that's 2 5 times. 3 sick days were taken by 2 people. So 2 people took 3. 4 sick days were taken by 6 people. So that 4 is going to repeat 6 times. And I'm going to show you a shorter way to do this. I'm just introducing this frequency table like this so you can kind of get a gist of what I'm doing. 1, 2, 3, 4, 5, 6. And 4 people took 5 sick days. So one person took 5, another person took 5, excuse me, a third person and a fourth person. So really, and then 3 people took 0, 0. 3 people took 0. So really what you're doing is you got a whole bunch of numbers. You got the number 1 that occurs 9 times, which is just really 9 times 1, plus the number 2 occurred 1, 2, 3, 4, 5 times. So that's really just 5 2s. This 3 occurred 2 times. So you don't have to add these all up one by one. This 4 occurred 6 times. And the 5 occurred 4 times. So instead of adding them up all one by one, like 1 plus 1 plus 1 plus 1, I don't even want to finish all the ones. You just do 9 times 1 plus 5 times 2 plus 2 times 3 plus 6 times 4 plus 4 times 5. Now divide it by what? Because we're finding the average, okay? All right, another word for average again is mean. So we're going to add up all the numbers. So add up all these. I use the shortcut. I don't even worry about the 3 zeros. You could have put 3 times 0 on here, but anything times 0 is 0. But we still need that for this, okay? So what do I divide by? I divide by the number of sick days or the number of people that took the sick days, okay? So what I want to do is see how many people, how many of these employees, what the average is as far as the sick days they've taken. Because it says the supervisor is examining the number of sick days that employees use per year. So I want to divide by the number of employees to see on average what does what kind of days does an employee take for sick days, or what number of days does an employee take for sick days throughout the year. So I want to divide by the number of people, okay? So although 3 people didn't take any sick days, those 3 people are still included in my total. So 3 plus 9 plus 5 people there, plus 2 plus 6 plus 4. All right. So I'm going to tally up all my people. Don't tally up the sick days. Tallying up the sick days is on the top. Tallying up the total number of people will be on the bottom. Okay. So this is going to end up being sick days on the top, taking per person on the bottom. Okay. All right, sick days per person. That's your average. So you know to put the sick days on the top and the people on the bottom, okay? Number of people. So I'm going to go ahead and I already know 3 times 0 is 3. I'm going to do this in black. 3 times 0 is 3. Excuse me, 0. 3 times 0 is 0. Plus 9 times 1 is 9. Plus 5 times 2 is 10. Plus 2 times 3 is 6. Plus 6 times 4 is 24. Plus 5 times 4 is 20. And I'm going to divide that all by my number of people. So how many people do I have? 3 plus 9 is 12. 12 plus 5 is 17. 17 plus 2 is 19. 19 plus 6 is 25. And 25 plus 4 is 29. There's 29 employees there. Okay. So I'm going to keep going. Let's see what this average is on the top. I got 0 plus 9, what the sum is on the top. 0 plus 9 plus 10 plus 6 plus 24 plus 20 is 69. So I got 69 divided by 29. Now keep in mind on the top is the number of, so 69 sick days were taken and over by a total of 29. I'm going to use the word by the total of 29 people. You wouldn't say people per sick day. You would say sick days per people. So make sure the total number of sick days are on the top and the people are on the bottom. So let's do 69 divided by 29. And I'm going to round this off to the nearest tenth. To the nearest tenth, this is going to be approximately 2.4 sick days on average per person, guys. So 2.4 is the average. Now, when you get this table and the numbers over here keep repeating multiple times, like 0 repeated 3 times, 1 repeated 9, 2 repeated 5. Instead of trying to count these numbers up one by one like this up here, just multiply. All you have to do is multiply 3 times 0, 9 times 1, 5 times 2, 2 times 3, 6 times 4, and 4 times 5. Add those all up after you multiply and then divide by the total number of people. Again, it's sick days per person. All right, so let's take a look at this one. It says, below is a table of hourly wages for receptionists working for various companies. What's the average wage? Average, again, is mean. Again, is mean. This is not a frequency table. It's just a table. So I can see that a receptionist at J&D Company makes $11.35, whereas the receptionist at Smith Incorporated makes $12.15, and then so forth. So what I'm going to do is I can tell that in this survey, 1, 2, 3, 4, 5 companies were surveyed about the pay per hour of their receptionists. So let's take a look. I'm going to add all these numbers together. And I'm going to divide by how many companies provided that information for their secretary. That's 5 secretaries, 5 pays. Take 1135. Let's get the sum of the numerator, the stuff in the top. 12.15 plus 11.85 plus 11.15 plus 11.50. That's going to give us $58 divided by 5 companies. Okay, and I don't want to say companies, but I'm going to say receptionists because the companies actually surveyed their receptionists. So when I take 58 and divide it by 5, I can see on average that receptionists make $11.60 per receptionist, guys. On average, that's what they make. So when I say average, if you take all these numbers right here and put them in order from greatest to least, $11.60 or least to greatest, $11.60 will kind of be like the middle ground for those, okay? For those numbers. All right, let's talk about what an outlier is because an outlier can greatly affect the mean. An outlier is something that is not like any of your other data. It's off. It looks like it doesn't belong. An outlier can really skew your mean. It can make your mean look much higher or much lower than what it actually is. All right, so it's a value that is very different from the other values in the set. Like I said, it looks like it doesn't belong, okay? It makes things look much. It's one value that's much greater than other values, but it could also be much less than other values, okay? If it's much greater than other values, the mean is going to be greater than the other data. But if it's much less than the other values, and your mean is going to be lower than the values, it's going to really, really drop it. Anytime you have an outlier, I want to tell you that the median or the mode is going to describe the data better. So if you have an outlier in your data, please listen. Don't use the mean to find the average because it's invalid. It's not a real representation of the center of the data. For instance, you see how most of the data numbers are down here, but then you got this one piece of data that's way out there and it's pulling your mean up. It's like your center is right here, which is outside of, it's farther than these pieces of data. But really, if this outlier were not here, the average would not be here. It would be somewhere in the middle, like right in there, okay? But because of that outlier, this high number, because of this high number right here, it's taking these and making it, adding a big number to it, makes the mean go up higher. And so I'm going to show you what I'm talking about, but I'm going to do a average of data where the outlier is very different, but it's low instead of high. Then I think I have one where it's high instead of low. I know there are some, so we'll look at it, okay? All right. So I went the other way. I did where it's much lower. So I'm going to give you an example of a mean with an outline. It says Julie's scores on the math test this year are 85, 87, 92, 35, 90, and 92. So Julie is mostly like a high B or A student, except for one thing. For some reason, Julie has a 35 on the math test. Now, I know as a math teacher, if I know I have a student who makes mostly A's and B's, and then they fail one test, I know to go back and question it because something went wrong, okay? All right, we're going to find the mean of Julie's test score. So I'm going to show you something. I'm going to take all these scores and add them together. That's 1, 2, 3, 4, 5, 6 test scores. And you're thinking she made mostly A's, A's, low A's, and high B's. So, you're thinking, she's probably going to have, like a high B. Okay? All right, so we're going to divide by the number of numbers, test scores, which is 6. But let me add up her scores: 85 plus 87 plus 92 plus 35 plus 90 plus 92. So overall, she has a total of 481 points divided by 6. Now let's see what happens. Her average is approximately an 80, okay? But if you look at her test score, 85, 87, 92, 90, 92, is there anything like really close to an 80? All of her grades are above an 80 except this 35. So her average would have been higher, But this 35 took all these upper level B's and these A's and pulled it down to almost a C. Okay? So you have to be really careful. Although you may be an AB student, if you fail a test, it can really, really drop your average significantly, because an AB student that fails a test now has an outlier in their data, which is going to drop their score. Okay. Same thing for like a, a F or D student who turns around and makes like a or 100 on the test. It's going to pull it up much further than what it should be. Okay. That would be your outlier. All right, mean facts. This measure can be drastically affected by the addition or deletion of numbers in the data. For instance, if I took this 35 out, I promise you that Julie's test scores, her average would end up being somewhere in the mid 80s, like upper level 80s. All right, it wouldn't be a low, like almost a C, if I omitted that number. Outliers will distort the data either too high or too low. It's gonna make it look like most of Julie's test scores were around the 80, when I can clearly see most of her scores were not around a low B, almost a C. None of them were. Okay. But to distort means it's invalid. It doesn't really represent what Julie scored or the actual data. The mean is used when the data is closely gathered together. All right, this is usually the best choice to describe data unless there is an outlier. So if all these numbers were closely related to each other, then fine. I would say using the mean is great. But I would not use the mean in this case. Now we have to for grades, because whatever grades you make, we have to average it. But do I think that it will be an accurate representation of your average? No, I don't, because I know this is an outlier. So to be honest, when I calculate your averages, I know that you you can do better than an 80. You're better than an 80 or like almost a C student. You are really an A or B student. It's just that F that skewed your data. So the mean is not really the best way to represent the data, though, because for somebody else it would make somebody else think that you were like a C student, a low B student. All right, with an outlier, the mean can no longer be a good measure. So when you have an outlier, don't use the mean. That's basically what that says. All right, we're going to skip this because I did not put the numbers on here. So we're going to skip that. All right, using the median when the mean is not a good representation of the data. Simply put, they're outliers. So the mean can only not be a good representation when you got outliers. All right, so what you would do, let's talk about median since I brought it up, okay? The mean has one disadvantage. It's very susceptible to the influence of outliers. For example, consider the wages of a staff at a factory. Okay, 10 staff members make $30,000, and then, however, inspecting the raw data suggests that this mean value might not be the best way to accurately reflect the typical salary of a worker, if most workers only make like $12,000 to $18,000. So just because 10 of them make 30,000, but most of them make 12,000 or 8 to 18,000, that's not going to represent your mean. Okay. So we're going to learn how to take the median of that data. So let's look at median when the mean has outliers in it. Okay. All right. Finding the median of Julie's test scores. That's what you want to do. First is find the median of Julie's test scores. B, why is the median a better measure of central tendency than the mean? Everybody should know it's going to be because of there's an outlier. Now, we've already done this problem. I don't want to do it again. We ended up with 481 over 6. And that was approximately an 80. All right. Oh, I'm finding the average again. I'm sorry, you all. All right. I'm supposed to be finding, excuse me. The median is an average too, but I was finding the mean as an average. It says find the median as an average. So what you want to do is arrange the ages in numerical, not ages, tests. Okay. We're going to arrange the scores in numerical order. And then we're going to find the middle number. If there are two middle numbers, then we're going to find the average of them. In other words, the mean of them. So let's take these test scores and put them in order from least to greatest. So that'll be 35. All right. And then next would be 85. And then next would be 87. And then 90. And then we have two 92s. You can also put them in order from greatest to least. It really doesn't matter. I want to get the middle number, so I got the first and the last out of the way. The second and the second to last. And I can see that there are two middle numbers left. So you're going to find the average of these two. So you're going to take 87. You can take 87 and add it to 90 and split that in half because it's two numbers. If there was only one number in the middle, then all you would do is just write that one number as your median. But this has two, so I got to find the average of those two middle numbers. So that's 177 divided by 2, which is 88.5. So basically her score is about an 89. I forgot to clock in. Hold on, guys. So basically her score is about an 89. And I told you, like, if she had not scored that 35, and I said Julie is basically an AB student, but using the mean, her average was an 80. But using the median, her average is about an 89. And to me, that's much better. That's more reflective of her scores. Her scores are mostly high B's and low A's. So this is about the middle, okay? So to me, the median would be an accurate reflection or a better representation of her grades, guys. So I'm going to put this. It says, why is the median a better measure of central tendency than the mean? Most of her tests or scores are we'll say from high B's to lower A's. So 88 will be in the middle of some high B's and lower A's. That's a better center than an 80. An 80 is way below these, okay? So even if I put these numbers on a number line, I'm going to do these in tens so you can see more what I'm talking about. All right, so an 85 would be dead in the middle. An 87, maybe right here, okay? In red. 92 would be a little above a 90. She had two of those. And then, of course, we did have the 90 exactly. Do it in purple. And then, of course, you had this 35. I'm going to do it in white. It's way down. Let's not do that in white. Let's do it in orange. That's 35. It's halfway between 30 and 40. Using the mean, it said that, and these were her test scores. All of them, everything on this line. Okay. Using the mean, it says most of her grades this was the center. That was the center of her grades. Like most of her grades were around an 80, a low 80. Okay. So I don't see most of her grades being around a low 80. I see most of her grades of being an 85 or above. But when I use the median, it says that her grade maybe lies, this is the middle. And to me, that's more of the middle of most of her grades. This 80 is not a middle, okay? It's not a center. All right, so the best choice if you need to select the most popular value. So when it comes to most popular or favorite, go with mode. So you can identify the number that appears most often. If two or more numbers appear equally more often or with the same frequency, then each of the numbers is the mode. So you can have more than one mode. So when I say, like if I have something like this, then the 2 appears 2 times, and the 3 also appears 2 times. They appear equally the same amount. So your mode would be 2 and 3. All right, now if you had another 3 here, then the 2 appears 2 times and the 3 appears 3 times. So you would go with the mode of 3. All right, if all the numbers appear with the same frequency, then there's no mode because there's no number that appears more so than the other. Okay, so let's take a look at this one. You work at a shoe store and your manager is about to order more shoes. The manager wants to record the sizes of women's shoes bought on a particular day to figure out which sizes sell more. You record the sizes of women's shoes bought on Tuesday. What would best represent the average women's shoe size? So I'm gonna go back up here. When you are talking about the most popular item that sold, something like that, or favorite, always use the mode. Okay. Okay. All right. So I'm looking at these 7.5, 8, 8.5, 7, 9, 8.5. I see 8.5 appearing 1, 2, 3 times. What about 8? 8 appears 1, 2, only 2 times. What about 9? 9 appears 1. That's it. 7.5 only appears twice. Nothing more than 8.5. 6.5 once. 9.5 once. So the mode is going to have to be 8.5. So basically, most women wear size 8.5. That's all that means. You can't change that. I mean, that's what was bought the most. So most women on average have a shoe size of 8.5, according to these records. All right, so let's take a look. It says we got some more examples. We're going to find mean, median, and mode. We're not going to be plotting the data on the number line. I don't think you have to do that on your work keys test. But we will talk about which value best describes the scores and why. And we won't do all these. We kind of skip around. It says now scored 70, 74, 72, 71, 73, and the 96 on 6 geography tests. Use the mean, median, mode of his scores to answer each question. So I can tell now is just really a C student, but then I got this 96. Okay, so I'm going to find the mean. I'm going to go ahead and add these up. And then I'm going to divide by 1, 2, 3, 4, 5, 6. I'm going to take my calculator and add. So we have 70 plus 74 plus 72 plus 71 plus 73 plus 96. All right, so that's going to give us 456 divided by 6. So it's saying his average is like a 76. But most of his test scores are below a 76. Like none of them are actually even that. Well, 74 is close, but nothing is above a 76. All of them are below that, except that one score. So let's put these in order and find the median. 70, 71, 73, 72, 73, 74, and 96. So outside. Okay. We have two scores in the middle. So halfway between 72 and 73 is 72.5. That's the median. You could have just taken 72, added it to 73, and then divided them by 2. And it still would have given you 72.5, okay? But I just know halfway between 72 and 73 is 72.5. Okay, so most of his scores are in between 70 and 74, and 72 is like in the center of 70 and 74. So that's pretty good. That's, to me, is what we want, not this one, okay? All these scores, none of them are even a 76, so how can you have a 76? That can be a good representation. The mode, there is no mode. All of the numbers only appear once or equally the same amount of times. Don't put 0 for the mode because you're telling me the number 0 exists. All right, which value best represents now scores? And so this would be the median. And I'm going to put because there's an outlier. All right. Let me see. I'm not going to do all these, but let me see what I can do. Okay, let's take a look at this one, I believe. We'll do this one. We'll do C and D. Customers at the Brooklyn Steakhouse, Peter Ligure, were asked to rank the customer service satisfaction on a scale of 1 to 10, with 1 being the worst and 10 being the best. This is another favorite. All right, the most popular. The results of a random group of customers on Tuesday night are shown. So anytime you ask for like the results of a survey that require you to put a rank or something like that, I can already tell you it's going to be the mode, okay? So 10, 10, 10, 10, 10, 10. I'll go ahead and put the mode as 10. It appears more so often than anything else. All right, I can tell you it won't be the mean because you have an outlier one. One person just felt like, this restaurant sucked, and it's going to drop their score significantly. And when most people thought they were 8, 9s and 10s, 8, 9s and 10s, high scores. All right, here, the median, let's go ahead and find it though. 1, 2, 3, 4, 5, 6. 6 10s is 60 plus 9 plus 1 plus 9 plus 8 plus 8 plus 9. So let's make sure I have the right amount of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's 6 numbers that can't make that 60. 7, 8, 9, 10, 11, 12. I'm missing something. How many 9s do we have? 1, 2, 3, and we have 3 8s. I'm missing an 8. Okay, I'm going to divide by 13. 6, 7, 8, 9, 10, 11, 12, 13. 60 from the 6 tens plus 9 plus 1 plus 9 plus 8 plus 8 plus 9 plus 8. That's going to be 112 divided by 13. Let's see what that gives us. 8.6. Well, most of the scores are like 10, so 8.6 is pretty low. But most of them are, 6 of them actually are 10s. Now, if you put these 13 numbers in order, then you would have 1 as the smallest. Let me do this one in a different color. You would have 1 as the smallest, and then you have 3/8. You have 3/9, and you have 6/10. 1, 2, 3, 4, 5, and 6. So I'm going to work my way to the middle number. The middle number is a 9. 9 would be pretty. It would be a good source of a way to represent it too. But I'm going to go with mode because most of these scores were 10 and you're talking about ranking, okay? So which value best describes the steakhouse's scores? Let's go with mode because most customers scored, give them most, gave a ranking of 10. Okay, most customers gave a ranking of 10. Normally, when you, like I said, when you're asked to find like the most popular brand or like a survey of satisfaction, that's going to be using the mode, okay? And let's take a look at D. Let me see what else we have. I'm going to do a second video for weighted mean. We're going to take a look at D, and then I make another video for weighted mean. You drive a school bus in a suburb. You record the number of minutes that it takes to complete your daily route for 2 months. The data are listed in a frequency table. You need to describe the typical route time and then which measure best describes a typical route time. Okay, so I'm going to find the typical route time. I'm going to see if I should really use the mean, median, or the mode. Okay, so we're looking for route time, so I'm going to focus on the number of minutes because minutes is time. All right, so 26 days, that school bus took a time of 17 minutes to complete the route. Now, keep in mind, this is over the course of 2 months. So that 26 actually happened 17 times. Plus 2 days, it took them 18 minutes. So you're going to have 18 appear twice. 5 days, it took 20 minutes. So 20 minutes is going to appear 5 times. 6 days, it took 22 minutes. And 1 day, it took 55. Woo! That's definitely an outlier because had to be a traffic jam or an accident somewhere. Because most of these scores are between 17 and 22, not 55. Something happened that day. Probably was a lot of worried parents trying to figure out why that bus was that late. All right, now, what am I going to divide this by? So this represents the number of minutes. So this has to be the number of days, okay? So I'm going to be looking at, on average, what was the number of minutes per day? So I'm going to add up these days. Okay, so 26 plus 2 is 28. 28 plus 5 is 33. 33 plus 6 is 39. Plus 1 is 40. You know, you only go to school Monday through Friday. That's about 40 days, okay? So divide by 40, that's 2 months. 40 days in those Monday through Fridays in those 2 months. But let me figure out my sum in the numerator. 26 times 17 equals 442, plus 2 times 18 is 36. 5 times 20 is 100. 6 times 22 is 132. And that's just 55. Divide by 40. Okay. Add these numbers up. 442 plus 36 plus 100 plus 132 plus 55 is 765 divided by 40. Okay. 765 divided by 40 is 19.12. So on average, we're going to say 19, and I'll round this up to the nearest 10. That's how many minutes the average route time was per day. Okay. So I know you have one number that's an outlier, and it made it go up a little, but not a lot, because this outlier did not happen a lot of times. What happened a lot of times was this 17 minutes. Okay. But this is going to be the mean. It didn't really affect, because 19, if I look at most of this data, 19 is a good measure of center. 19 is 17, 18, 19, 20, 20. 19 will be somewhere in the middle. Again, this didn't really affect it, although it is not outlier because it was only one number out of 40. Okay. So it didn't really have a major pull on it. Even if I remove that 55, so I'm going to go back and take 765 and remove that 55, and then divide it by 39. You get 18.2. So it had somewhat of like 9/10 of an effect on it. It pulled it up by 9/10 of a minute, which is not very much at all. So we're going to go with mean, because most of these numbers are all clustered together. Can you imagine 26 17s, 2 18s, 5 20s, 6 22s, 6 17, 18, 20, and 22? They're pretty all clustered together, but you got many of these 17s. Okay, so that's what makes that better, and you're able to use the mean. All right, I'm gonna pause. I'm gonna stop this video, and in the next video we'll talk about weighted mean.